Hello everyone, my name is Sebastião.Quintas and I'm here today to present our paper entitled Can we use speaker embeddings on spontaneous speech obtained from medical conversations to predict intelligibility? So first and foremost, I'll start by give a quick introduction on the topic at hand. So perceptual measures such as speech intelligibility and speech disorder severity play an important role in the assessment of speech affecting disorders such as head and neck cancer and Parkinson's disease, for instance. These measures are known to be biased, subjective, and variant, since the evaluation or their perceptual evaluation can depend on a variety of aspects. And therefore, an automatic approach has been seen as a growing alternative that could counter this subjectivity. From the literature, different approaches are used and can be found to automatically predict speech intelligibility and speech disorder severity, such as systems based on automatic speech recognition performance, more traditional signal processing approaches, or even fully data-driven systems as well. Despite the promising and interesting results displayed by these approaches, these systems are typically developed and tested in data that hardly mimics real hospital conditions. Given this, in the present work, we intend to first analyze the reliability of an embedding-based intelligibility system on data recorded under real clinical conditions, and second, assess the reliability of the same system when predicting intelligibility based on spontaneous speech segments obtained from patient and doctor interviews. So now, with the introduction out of the way, I can introduce the methodology, and more specifically the system that we created in order to predict these two measures. Our system is based on speaker embeddings, as you can see here, that receives as input the different speech tasks that I will introduce later on during this presentation. Two embedding types are used, first the X vectors and then the AKTDN and speaker embeddings, both extracted using the SpeechBrain toolkit. And furthermore, those vectors, they are passed to a subsequent set of layers, fully connected layers with the dimensions written here. And then finally, to two also fully connected layers or prediction layers that aim to predict exactly these two measures. First, speech disorder severity and then speech intelligibility. Given the high correlations typically found between these two measures, so intelligibility and severity, the system was trained or is trained using a multitask learning methodology where both measures are equally taken in consideration in the loss function, 50% each. And we do this because we hypothesize that the tandem learning of these two measures will conduct to a better estimation. So now I can jump in the experiments and results that we performed with the aforementioned methodology. So for training and validation, we use the French head and neck cancer speech corpus, or the C2SI speech corpus, and more specifically the passage reading recorded in the context of this corpus. A total of 98 speakers were used for training, and a subset of 10 speakers with varying degrees of intelligibility was used for validation. As far as testing is concerned, we tested our system with a different corpus, but that recorded a very similar set of speech tasks that I'll explain right away. And this corpus is entitled the SpeakComco corpus that aims to reflect the real deployment environment of this class of systems. So all of the corpus was recorded in real clinical conditions. In this corpus, we have 27 head and neck cancer patients with varying degrees of intelligibility as well. And the different, as I previously said, the different speech tasks were also the same between the two corpus. So now we can examine the results obtained here. First, I'll just give a quick introduction on the speech tasks that you can find here, that are the same here. So the first task recorded for both corpora was the passage reading task. The second one was a semi-vowel sentences. It's very similar to the passage reading task, but shorter. And it's essentially two sentences that contain the semi-vowels that were not present in the original passage reading. We also have a consonant inflection task where the same sentence is repeated, however, with the emphasis on different consonants. We have a pseudo-word task as well that contains words that are non-existent in the French language, but respect French phonotactic and orthographic rules. And finally, we have the spontaneous speech tasks, where the speech segments were obtained from patient-doctor interviews. Given the variety and the variance associated to this task, the different patients have a different set of segments, and we kept the segments between 3 and 10 seconds using a voice activity detection from the full interview file. And then based on that, we regress severity and intelligibility for each one of the segments, and then we perform the average, so we have a global score. As far as the results obtained on this first column, we can see the results for speech disorder severity with the 2 embedding types, so a kappa TDNN and X factors, as well as the results obtained for the 2 evaluation metrics, the first one being a Spearman's correlation and the second one a root mean squared error. The same thing can be found for intelligibility as well. And concerning the results, we can see that pretty much in all cases, the X factors outperformed the kappa TDN and speaker embeddings. For speech disorder severity, we're able to obtain a high correlation for the passage reading task, both correlation and also an interesting error. While for speech intelligibility, these results were even better. We were able to achieve a correlation as high as 89% on the same passage reading task. So it was the same passage reading task that was used during training, however recorded with a different set of patients, of course. And then for the semi-vowel sentences, we're also able to obtain a very interesting correlation in error pairs. And furthermore, the results obtained on spontaneous speech, besides not being as good as these 2 prior tasks, they still remain highly interesting and highly promising as well. Here we can see the results of the plot of the 27 patients when testing the X factors on the spontaneous speech task. So for our discussion of the results, we will focus on 2 main topics. The first one being the speaker embeddings used, and the second one, the speech tasks used. Concerning the speaker embeddings, despite the kappa TDNN speaker embeddings outperforming the X vectors in the original task, so for speaker verification, in our specific context, X vectors still remain the best for both intelligibility and severity prediction, which is an interesting finding that also corroborates some other findings around the automatic assessment of pathological speech and how X vectors are and still remain very valuable for this type of assessment. And the second topic of discussion is concerning the speech tasks. So besides consonant inflection and the pseudo word tasks not being as good as the other ones, the X factors pretty much displayed solid correlation and errors on the remaining tasks, showing a good generalization ability to a variety of different tasks and even spontaneous speech. So showing that this system can be highly adaptable to different types of speech materials, besides being trained on a passage reading task. So now I'll just give a couple of perspectives on the present work. The development of a multi-pathology system becomes an interesting lead for future work. So this system is targets essentially head and neck cancer speech impairments, but with more data and better adaptation, we can generalize the system to a variety of different pathologies. And it's also important to say that different pathologies have different issues associated to them that reflect directly on these predictions. The prediction of other perceptual measures can be added value also to this system. So instead of predicting only speech severity and speech intelligibility, we can also adapt the system to predict voice quality, resonance, prosody, or phonemic distortions that are all also other clinical measures that are used in this type of assessments. And well, the results obtained, the high correlations and low errors also suggest direct clinical implementation through the means of a mobile device application to be used by doctors and therapists alike. That's a very promising lead for future work that we are currently working on. So we're getting really close to the end of this presentation. I'll just finish up with some conclusions. So in the present paper, we investigated the reliability of an embedding-based intelligibility system on real hospital data. A good generalization ability was found with correlations going as high as 89% and root mean squared error values as low as 1.32. And more interestingly, the metrics obtained on spontaneous speech are not only comparable to the other tasks, but also point to a more deliberate use of this type of speech material in this category of automatic assessments. So that will be it for my presentation. I want to thank you all very much for listening to it, and don't hesitate to reach out in case you have any questions, remarks, or comments that you would like to pose. So thank you all very much.